Today's lesson, as you could see, it's also reflecting or about the waves. We will continue work about both of them. And you have to know here that we are speaking about the diffraction inside the waves. We already finished the part that speaks about reflection, refraction, and there's the third way of working on this waves properties, which we call it diffraction. Inside of the diffraction here, you can find that you have to learn for this what happens when a plane waves passes through a hole in a barrier, and also how this is going to affect the changes when this hole is made more smaller. To understand this, you have to go also for the other part that is applied in normal wave on a real life situation. So we can say here that we have to understand what happens when a plane wave meets a barrier that blocks its path, and also how this is going to affect the radio and TV signals later. To understand the diffraction that happens in a white slit, you have to know that when you start to get this diffraction, when the wave is passing through a barrier over here, it's going to be diffracted. Diffracted, which means it increases. So if this is the incident ray that moves into an area, it has a tiny hole over here. This tiny hole makes the work diffracted into different directions, and it becomes more and increasing. Okay, you can find this way. It's just like when the water is found in the river tank program that we already spoke about before. Okay, you can find here even in this white slit that it has to be diffracted by the waves where you. So when you start find this barrier when it's working on this white slit, you can find that any incident wave when it's working over this barrier, it will start to move into this tiny hole, and by this it's going to increase its way of production. This is what we can call about it the diffraction of a wave. Okay, the same happens here, but in a narrow slit. This is a wide slit. The previous one was a wide one. This is a narrow one. When it passes through this narrow into the incident wave, it will find that the movement for this wave it's a little bit small, but when it's diffracted, it will become bigger. The diffraction here that happens to the wave is different from the narrow to the wide. That means when you start to decrease the distance or the rule for the hole over here, it can make the bigger or higher than normal. And you can see that the diffraction doesn't take a small angles, no, it takes a huge one. Okay. So when the diffraction happens in most of the objects, before you reach this part, you can find that the wave starts to move like the shape of this. This is how the incident wave is moving. This is the width for the hole that you are using. And you can find that it has the same wavelengths, but you have to find that the diffraction, which means the angle of incision, and also the spreading of these waves is getting larger than before. If there is a diffraction that happens on an obstacle, what would happen? Here is the barrier, and when the incident waves find something to stop on, and there's a barrier, you can find that the diffraction would be working like this. So there is an area where the sound is diffracted here at the middle. You cannot hear anything inside it until the waves they connect back together, and then they turn to the normal. This is the incident wave. This is how it's diffracted. So we have here right now 3 ways of diffraction: wide hole, narrow hole, a barrier that stays on the front of it, and the obstacle here, it takes the area where the diffracted wave is taking this shape. If the wavelength is longer than normal, or object that is smaller, then you will find that the waves move more into the shadowed area. And this happens, as you can see, when there is a TV or radio waves that are traveling from a place to another place. You can find here that radio waves is always being catched or attracted because of what? Because of the diffraction of the waves. So he asked me, why do radio waves bend or diffract more than the TV? And this happens, as you could see, because there is a barrier over here that stands in front of it. It takes like a narrow hole that is in front of it and makes it diffracted with the large or a huge angles. Okay, this is for listen today.